In the Department of Anesthesia, we have two scopes for routine use. The first being a Storz. It's a wide diameter scope used for most oral intubations. The second is also a Storz scope, and this is a narrow diameter, can be used for placing of double lumen tubes or nasal fiber optic intubations. Each of these scopes can be used with an eyepiece for direct vision. That just snaps right on here like that. A battery-powered light source can be added to it. We just screw like that, and we turn it on by pushing the button on the battery pack. And I'll show you the light coming out of it. It's rather bright. In addition, an external light source can be attached to here with a special cable which will screw onto this. The eyepiece can be connected to the scope as such, pressing until you feel a firm click and it's no longer removable. In order to remove it, one presses a little lever in and lifts it off. The light source is added to the scope as such, if you want to use the battery powered. If you want to use an external light source, a cable needs to be attached in the same manner that the battery pack is. If an external light source is to be used on the Storz eyepiece instead of a battery, a Storz cable must be attached to the eyepiece as shown. The light cable shown on the right is an Olympus light cable and will not attach to the Storz eyepiece. Please do not try to do it. For viewing through a television screen, a TV camera can be connected to the end of the scope as such. Now, anything that is seen by the end of the scope can be viewed on the television monitor. A gray tube is also a light source. A light source can be found at the bottom of the television tower. With this system, the television monitor is turned on separately, the amplifier is turned on separately, and the light source is turned on separately, with the brightness being controlled by a sliding switch on the light source. The white balance is done by depressing the proximal switch on the television camera, while the television camera is connected to a scope and the light source is turned on and the tip of the scope is held over a white surface. We also have something called a telepack, which is a combined light source and TV combined, and the television camera for that is the same as on our other television monitor and snaps on like so. The telepack is turned on by pushing the left-hand button one click in. The light source is turned on by pushing the left-hand button two clicks in, a second click as far as it goes. The white balance is accomplished by depressing the right-hand button and is not accomplished by pushing a button on the camera like our other system. The television camera for the Storz system involves the black cable, which is the television cable, and a gray cable, which is actually the light source. The light source cable can be removed by just snugly pulling it out. Occasionally, one will find that there is not enough light coming through, and it's possible that the cable needs to be replaced. Both of our Stort systems are equipped with a light feedback feature. This feature allows the light to be very bright and the signal is cut down a bit as it comes through the television camera, so there's not a lot of glare. We recommend that the light source intensity be put on full, and it can always be decreased if you find there's too much light. The light source plugs right into this aperture. Here we are looking at a Stort's TV camera attached to a scope. In order to focus the screen on the television set, take your finger and move this dial back and forth until you see a sharp image on the television screen. When utilizing the Stort scope without a television monitor, there is no focus necessary as the scope is a fixed focus scope. As an aside, many of the scopes require the scope to be focused in addition to focusing a TV camera if one is used. In general, these Stort's scopes do not need lubricant on the shaft. Other scopes, such as Olympus, require a thin layer of silicone lubricant to be placed on the shaft of the scope in order to prevent the plastic on the shaft of the scope from adhering to the plastic in the endotracheal tube or trach tube, as the case may be. We recommend that suctioning only be done through the larger diameter scope, and if suctioning is done, it is suggested that the suction port be cleaned out immediately after intubation, otherwise the secretions will dry up, resulting in a costly repair. If a lot of secretions are anticipated and they're not very thick, one can connect an oxygen tubing to the end of the scope and connect the other end to a flow meter, which at about 2 liters per minute, and you'll be able to hold down the button on here and continuously deliver oxygen through the formerly suction port. In order to do that, however, one has to cap the scope, one has to cap the other port on the scope, otherwise the oxygen will just blow out that hole. We recommend that when the scopes are not in use, they be placed in a holder on either side of the TV monitor. The holders are capable of holding the scope and the TV camera attached to the scope at one time for stability. We recommend that the scopes not be left lying on flat surfaces, since people tend to put things on top of them. Now for a few words about equipment damage. The cords from the scope should never be allowed to be on the floor where they can easily be crushed. The camera and the scope should be mounted in such a way that they cannot fall on the floor. In this example, the lens on the scope was cracked from falling on the floor. Here, the fiber optic bundles have been damaged, most likely from crushing the scope. This image demonstrates water damage due to a scope being cracked. Here, fiber optic bundles have been damaged, probably from overbending the scope. The scopes have 2 channels to transmit the light. Here we see one has been completely obliterated due to crushing the shaft. This is a light cable that has either been crushed or overly bent. The upper image shows an intact light cable transmitting all of its light. In the lower image, most of the fibers are broken, resulting in very little transmission of light. This is another example of a light cable where most of the fibers have been destroyed. One of the common reasons for failure in fiber optic bronchoscopy is that there is insufficient light. So it is in everyone's best interest to protect the light cables, keep them off the floor, and keep them from being excessively bent.